Hello everybody. In this video we are going to review expectation and variance of discrete random variables. This is problem number 1. A game of chance involves rolling an unevenly balanced four-sided die. The probability that a roll comes up 1 is 0.16. So let's write as we are reading. So probability of getting 1 is 0.16. And we have four-sided unevenly balanced die. So we have numbers like 1, 2, 3 at the other side and number 4 in the bottom, like this. And the probability that a roll comes up 1 or 2 is 0.43. So the probability of 1 or 2 is 0.43. And the probability that roll comes up 2 or 3 is 0.47. If you win the amount that appears on the die, what is your expectation winnings? So we're going to compute the expectation of this event. We know that each event is mutually exclusive because two things here cannot happen at the same time. Think like head or tails in a coin. It comes either head or tails. It doesn't come two of them at the same time. So this is mutually exclusive. So knowing that this is mutually exclusive, probability of 2 is equal to probability of 1 or 2 minus probability of 1. And here, if we plug in numbers, 0.43 minus 0.16 will give us 0.27. Similarly, probability of 3 is equal to probability of 2 or 3 minus probability of 2. And if we plug in the numbers, 0.47 minus 0.27 will give us 0.20. So how about probability of getting 4? Probability of getting 4 is 1 minus everything because total probability is equal to 1. So it will be 1 minus probability of 3 minus probability of 2 minus probability of 1. And if we plug in the numbers, it's going to be 1 minus 0.20 minus 0.27 minus 0.16. 0.37. Now we're going to compute the expectation. Expectation by definition is x times p, the probability times the number of trial. So we're going to multiply 1 times 0.16 plus 2 times the probability of 2 is 0.27 plus 3 times 0.20 plus 4 times 0.37. So what we obtain is 2.78. So the amount he makes is $2.78. Problem number 2. 2 dice are tossed 252 times. How many times would you expect to get a sum of 5? Expectation is, by definition, xi times pi, which is the number of trial times the probability of that trial. And we know that here our number of trial is 252 times. So now we're going to compute the probability of sum of 5 for single die. So probability for sum of 5 is only given by if we roll 1 and 4 and 2 and 3 and 3 and 2 and 4 1. And if we combine these probabilities, that's going to be the probability of getting sum of 5. We know that probability of getting 1 is 1/6. Probability of getting each number is 1/6 in a single die. and this probability will be 136 plus 136 plus 136 plus 136. So that's going to be 4 out of 36, which is 1/9. So now we know that our P is 1/9. So the answer is 1/9 times 252, which is x times P. Problem number 3. The discrete random variable x has a probability distribution defined below. So we're going to compute the expectation of this random variable x. Again, expectation by definition is the sum of x times the probability p. So it's going to be 0 times 1/4 is 0, plus 2 times 1/8, which is 2/8, plus 4 times 1/2, which is 2, plus 8 times 1/2, which is 1. So if we add up all the probabilities, we obtain 13/4. Problem number 4. 2 balls are selected at random without replacement from a set that contains 5 balls labeled 1, 1, 2, 2, and 3 respectively. Let x denote the sum and y the maximum of 2 numbers drawn. By finding the probability mass function in each case, find the expectation of the following random variables. So here we're going to compute the expectation of x, y, x plus y, and x times y. Let's illustrate the situation. We have a bag, and in this bag we have the balls numbered 1, 1, 2, 2, and 3. So we have 5 balls in the bag. So the probability of picking 1 is 2/5. And probability of picking second one is, if we pick the second ball as 1, it's going to be 1/4 because we do it without replacement. Probability of picking 2 is again 2/5 because we have two balls out of 5. If we pick another ball 2, it's going to be 1/4. And probability of picking 3 is 1/5 at the first coordinate. At the second coordinate, probability of picking 3 is 0 because we have only 1, 3. So we're going to use this information. X is denoting the sum of 2 balls. We are picking 2 balls, and x is the sum of them, coordinate 1 plus coordinate 2. So the possible values of x is 2, 3, 4, and 5. Probability that x is 2 is the only way that we pick 1 and then we pick again 1. So 1 plus 1 gives us 2. Probability that x is equal to 3 is picking 1 first, then 2, or 2 first, then 1. Probability that x is equal to 4 is we first pick 1 and then 3, or we pick 2 and 2, or we pick 3 and 1. And probability that x is equal to 5, that we first pick 2, then 3, or 3 and 2. Now let's see the probabilities of each x here. So probability that we pick 1 at the first coordinate is 2/5. And 1 again at the second coordinate is 1/4. Without replacement, and we're left with 4 balls. Probability that we pick 1 at the first coordinate is 2/5. This is 2/4. And we're going to combine the probabilities here. Picking 2 is 2/5 and picking 1 is 2/4. 2/5, 1/4, 2/5, 1/4, 1/5, and 2/4. This is going to be 2/5, 1/4, and 1/5, 2/4. And we're combining the probabilities here. So the probability that x is equal to 2 is 2/20. And probability that x is equal to 3 is 8th 20th. Probability that x is equal to 4 is 2 plus 2 plus 2, 6th 20th. Let's write it here. And probability that x is equal to 5 is 2 plus 2, which is 4 20th. Now expectation by definition is x times p, number of trial times the probability that belongs to that x. So it's going to be 2 times 2 20th. So it's going to be 2 times 2 20th plus 3 times 8th 20th plus 4 times 6 20th and 5 times 4 20th. So this is the answer for expectation of x. Expectation of y, let's clean up here. So this time we're going to write out the possible values that we can get for y. Y is denoting the maximum numbers of 2 drawn. So we can minimum pick up 1, 2 and 3. Those are the possible values for y. Probability that y equals to y is the only way. We pick up 1 and 1 again. Probability that y equals to 2 is either we pick up 1, 2 or 2, 1. And the greater number is the value of x. I'm sorry, value of y. And probability that y is equal to 3 is either we pick up 1, 3, 2, 3, 3, 1, or 3, 2. Now let's see the probabilities of this. And we're combining these probabilities. So picking 1 is 2/5, picking 1 is 1/4, 2/5, 2/4, 2/5, 2/4, 2/5, 1/4, 2/5, 1/4, 1/5, 2/4, 1/5, 2/4. And probability that y is equal to 1 is 2 20th. This is going to be 2 times 2 is 4, 4 plus 4 is 8, 8 20th. So this is going to be 2 plus 2 is 4, plus 2 is 6, plus 2 is 8, 8 20th again. And expectation by definition is x times p, so it's going to be 1 times 2 20th, 1 times 2 20th, plus 2 times 8 20th, plus 3 times 8 20th. So this is the answer for expectation of y. Expectation of x plus y is the sum of these two expectations, because sum of expectations is equal to their addition. So whatever value we obtain here, so expectation of x plus expectation of y. Let's say we obtain here a and we obtain here b, so it's going to be a plus b, the values. Here expectation of xy will not be their multiplication because those are not independent. How do we know that? Because if we test for independency, let's do it here simply. If two events are independent, their intersection is equal to their product. So let's test out one of them. Let's, for example, pick up that probability that x is equal to 3. Probability that x is equal to 3 is 1, 2 and 2, 1 coordinates. And if probability of x is equal to 2, then probability of y has to be 2, because the greater value is denoted by y. And probability that y is equal to 2 is 1, 2, 2, 1, and 2, 2. And probability that x intersect y is, so only these are common, so it's 1, 2, and 2, 1. And probability that x is equal to 3 is, we computed that, it is 2/20. And probability that y is equal to 2 is, we computed that, it is 8/20. And this is 2/20. And if we multiply 2/20 times 8/20, it is not equal to 2/20. 2/20 times 8/20 is not equal to 2/20. So their product is not equal to their intersection. So we know that these two events are not independent. So now we're going to treat this x times y differently. Let's write out triple coordinates. So the first coordinate will be our x probability, the second coordinate will be y, and the third coordinate will be x times y. So probability that x is equal to 2 is only 1 and 1. In this case, the highest value here is 1, so y has to be 1. And if we multiply x times y, it's going to be 2 times 1, 2. And this is only 1, 1. Probability that x is equal to 3 is only this two coordinates. And in this case, y will be 2, the highest value. And then x times y will be 6. And that is only these two coordinates, 1, 2, and 2, 1. Probability that x is equal to 4 is only those three coordinates. And in this case, the y value will be 3. And x times y will be 12. Here, we need to separate this into two sections. We have y value 3 and we have y value 2 here. So in the coordinate 4, 3, 12, our only coordinates are 1, 3 and 3, 1. And in this case, our coordinates are 2, 2. And probability that x is equal to 5, then y value will be 3 and x times y will be 15. And only these two coordinates gives us this 5, 3, 15. Now we can compute the probabilities here. So this is going to be 2/5 times 1/4. This is going to be 2/5 times 2/4 plus 2/5 times 2/4. This is going to be 2/5 times 1/4 plus 1/5 times 2/4. This is going to be 2/5 times 1/4, and this is going to be 2/5 times 1/4 plus 1/5 times 2/4. And if we multiply, this is going to be 2/20. This is going to be 2 plus 2 is 4, 4/20. This is going to be again 4/20. This is going to be 2/20, and this is going to be 4/20. Now we can apply the definition of expectation. So by the definition of expectation, we're going to multiply x times the probability p. So it's going to be 2 times 2/20 plus 6 times 4/20 plus 12 times 4/20 plus 8 times 2/20 plus 15 times 4/20. And this is the answer for expectation of x times y, because these two events are not independent. Problem number 5. The random variable x has mass function given below. Find e of g of x, where g of x is x squared plus 2x plus 1. Here we are going to compute the expectation of a function. So we need to find the value of function at that given points. So we need to know what g of 0 is, g of 2 is, and g of 3 is. G of 0 is, in this defined function, 0 squared plus 2 times 0 plus 1, which is 1. And g of 2 is 2 squared plus 2 times 2 plus 1, which is 9. And g of 3 is 3 squared plus 2 times 3 plus 1, which is 16. And we were given that 1/2 x is equal to 0. And g of 0 is equal to 1. So it's going to be 1 times 1/2, which is 1/2. And 1/3 x is equal to 2. And g of 2 is equal to 9. So 1/3 times 9, which is 3. And for g of 3, which is 16 times 1/6, which is 16 over 6. And if we combine these, we obtain the expectation by definition. So 1/2 plus 3 plus 16 over 6 is the answer. Problem number 6. A rock concert producer has scheduled an outdoor concert. The producer estimates the attendance will depend on the weather according to following table. What is the expected attendance? Again, by the definition of expectation, it's going to be the sum of x times probability p. So it's going to be 6,000 times 0.1 plus 30,000 times 0.2 plus 15,000 times 0.1 plus 40,000 times 0.6 will be the mean or expectation. Part B is asking if tickets cost $30 each, the band will cost $30,000 plus $55,000 for administration. What is the expected profit? So for this, first we need to know what the mean is. So if we execute these numbers, it's going to be 32,100. And the total cost is 300,000 plus 55,000. And our total receipt will be the expectation or the mean number times the price of the ticket. And expected profit will be this value, which is 32,100 times 30 minus the total cost. Total cost is 300,000 plus 55,000. So that's going to be the answer. Problem number 7. 4 buses carrying 160 high school students arrived to Montreal. The buses carry respectively 37, 50, 34, and 39 students. One of the students is randomly selected. Let X denote the number of students that were on the bus carrying this randomly selected student. One of the 4 bus drivers is also randomly selected. Let Y denote the number of students on his bus. Compute the expectations of X and Y. So we have 34, 37, 39, and 50 students are in each bus. And the probability of this is 34 out of 160. And probability of this is 37 out of 160. Similarly, 39 out of 160 and 50 out of 160. And by the definition of expectation, x times p will give us the expectation. So the answer here will be 34 times 34 out of 160 plus 37 times 37 out of 160 plus 39 times 39 out of 160, and finally 50 times 50 out of 160 will be the expectation. For expectation of y, again we have same buses and same number of students, but this time probability of picking one of the bus is 1 out of 4 because we are picking the bus driver here, and we have 4 buses and we are picking one of them, so it's 1/4, and equally likely they are each 1/4. And then expectation of y by definition is going to be y times p, which is 34 times 1/4 plus 37 times 1/4 plus 39 times 1/4 plus 50 times 1/4. And if you would like to condense it, you can make it 1/4 times 34 plus 37 plus 39 plus 50. Problem number 8. A fair die is rolled 19 times. What is the expected sum of 19 rolls? For single die, our expected value is 1 times 1/6 plus 2 times 1/6. That is the probability and the value of each number, plus 3 times 1/6, 4 times 1/6, 5 times 1/6, and 6 times 1/6. And we know this by heart. It is 3.5 is the average expected value of a single die roll. And we do this experiment 19 times. So if we multiply 19 times the average value of single die, we obtain 65.5, which is the expectation of the sum of the 19 rolls. Problem number 9. Below is a partially complete probability model. Enter the probability for the final outcome. So for this gap, we know that the total probability is equal to 1. So 1 minus everything, which is 75, 80, 90. So this is going to be 0.1 because that's the number that completes to 1. And expected value by definition is x times p, outcome times the probability. So 2 times 0.4, which is 0.8, 2 times 0.35, which is 0.7, plus 3.5 times 0.15, plus 3.5 times 0.1. And this is going to be answer for the expected value. Problem number 10. Find the expected value for the random variable. Expectation by definition is outcome x times the probability of that outcome. So here we were given explicitly in the table, so it's going to be 2 times 0.23 plus 3 times 0.19 plus 3 times plus 5 times 0.21 plus 7 times 0.37. So this is the expected value for this random variable x. Problem number 11. Suppose that from a standard deck you draw 3 cards without replacement. What is the expected number of diamonds you will draw? In this problem, we need to know first the number of diamonds. So we have 52 cards in standard deck and 13 of them are diamonds. And the rest, 3 other suites, are 39 cards. 13 plus 13 plus 13. So for the first card we are picking is the probability is 13 choose 1. And non-diamond cards are 39, choose the rest 2, because we are picking totally 3 cards. And our total number of combinations is 52, choose 3. So we can formulate this as sum d from 0 to 3, d times 13 choose d times 39 choose 3 minus d over 52 choose 3. So this is the answer. And if you would like to expand this, let me expand this. So it's going to be the first card we are picking, 1 times 13 choose 1 times 39 choose 3 minus 1, which is 2, plus second card is 2 times 13 choose 2 times 39 choose 1, 3 minus 2 is 1, plus the third card is 13 choose the 3 and 39 choose 0, and all over 52 choose 3. Either this form or that form is the answer. Problem number 12. For a random variable x, suppose that expectation of x is 5 and the variance of x is 10. Then what is the expectation of 5 plus x, the quantity squared? So for this, first we're going to expand 5 plus x. So we're going to do binomial expansion. So it's going to be 25 plus 10x plus x squared. And that is equal to 25 plus 10 times expectation of x plus expectation of x squared. Here we know expectation of x given 5, but we don't know expectation of x squared. Variance of x by definition is equal to expectation of x squared minus expectation of x, the quantity squared. And from here, if we solve for expectation of x squared, we obtain that expectation of x, the quantity squared, plus variance of x. So we can substitute expectation of x squared as this. And when we switch variance of x to the right hand side, it is still positive because variance is always positive by definition. Now, instead of expectation of x squared here, we are going to replace expectation of x, the quantity squared, plus variance of x. And we know the numbers. This is going to be 5 squared, and this is going to be 10. And it's going to be 25 plus 10 times 5 plus 5 squared plus 10. We obtain 110. Part B is asking variance of 2 plus 6x. Let's remember these two formulas. Expectation of a plus bx is equal to the constant a plus b times expectation of x. And variance of a plus bx is equal to b squared times variance of x. So knowing this, we can execute variance of 2 plus 6x as 6 squared times variance of x, which is 6 squared times, we know the variance of x, which is 10. So it's going to be 360. Problem number 13. Find the mean, variance, and standard deviation for the probability distribution given below. So mean or expectation by definition will be x times p. So it's going to be negative 4 times 0.558 plus 7 times 0.101 plus 11 times 0.213 plus 9 times 0.128. So this is our mean or expectation. If you plug this in your calculator, you're going to obtain 1.97. Variance by definition is expectation of x squared minus expectation of x, the quantity squared. So we need to compute the expectation of x squared. And expectation of x squared is exactly the same with the squared forms. And this value will give us 50.018. And if this is 50.018 and if this is 1.97, then we square it, and then what we're going to obtain is this value minus this value, which is 46.1371. And the standard deviation is the square root of the variance, so it's going to be 46.1371. So standard deviation sigma is equal to square root of variance. Problem number 14. When parking a car in a downtown parking lot, drivers pay according to the number of hours or fraction thereof. The probability distribution of the numbers are given below. So we're going to calculate the mean, standard deviation, and the cost of parking $2 per hour, and the standard deviation of the amount of revenue each car generates. So let's start with the definition of mean. The definition of mean will be xi times pi, which is x times p here, given explicitly. So it's going to be 1 times 0.238 plus 2 times the second probability, 3 times the probability of 3, plus 4 times 0.096. Actually, I did it. Let me paste it. So it's going to be finally 8 times 0.297. And that number will give us the mean. And standard deviation is the square root of the variance. For variance, we need to find expectation of x squared and then subtract expectation of x squared from expectation of x squared by definition. So expectation of x squared is, let me do it here, 1 squared times the probability, 2 squared, 3 squared, 4, 5, 6, 7, and 8 squared times the probability that belongs to that x. And that is this number. So 26.641 is the expectation of x squared. We already found the expectation, which is 4.331, and if we square this two quantity, we obtain the standard deviation. Now the cost of parking is $2 per hour, so if we multiply 2 times expectation, $2 times the expectation will give us the answer, which is 8.662. And the standard deviation for this will be $2 times standard deviation. And standard deviation is this number minus that number. So it is this. So you can plug in either in this form or in that form. Problem number 15. We were given expectation mu 2 and variance as 3. So we're going to compute this. Let's remember the formula. Expectation of a plus bx kind of argument is equal to a plus b times expectation of x, and variance of a plus bx is equal to just b squared times variance of x. So the constant here is ignored. So here expectation of 2v plus 6 v is here the variable v, not the variance v, is equal to 2 times v of x plus 6. So it's going to be 2 times mu is given as 2 expectation plus 6. 2 times 2 plus 6, 10. For variance, instead of 2v, you can consider it as 2x. 2v plus 6 is equal to 2 squared times variance of v or x, whatever variable you consider. So it's going to be 4 times 3, 12. Variance is given here. And this is the same because that constant has nothing to do. Problem number 16. 4 buses carrying 152 high school students arrive to Montreal. The buses carry respectively 33, 44, 30 and 45 students. One of the students is randomly selected. Let X denote the number of students that were on the bus carrying this randomly selected student. One of the 4 bus drivers is also randomly selected. Let Y denote the number of students on his bus. Compute the expectations and variance of X and Y. So for random variable X, we have 30, 33, 44 and 45 students. Total 152 students. And the probability for this is 30 out of 152. And probability for this is similarly this. And expectation will be X times P plus X times P plus X times P plus X times P. So the expectation here will be 30 times 30 out of 152 plus 33 times 33 out of 152 plus 44 times 44 out of 152 plus 45 times 45 out of 152. For variance, we need to find the expectation of x squared. And expectation of x squared is when we square them and then multiply by the probability. And that number will be our expectation of x squared. And we're going to deduct that from that expectation of x squared. So variance by definition is expectation of x squared minus expectation of x, the quantity squared. Let me paste the table here and then we can work on that. So variance of x is, we calculate the expectation of x squared here by squaring each x value and multiplying it by the probability of those x values minus the square of the expectation, which is 39.144. So we apply this formula. And expectation of y is the probability of picking each bus driver is 1/4. And we have 33 students in the first bus, so 33 times 1/4 plus 44 times 1/4. Similarly, definition of expectation is x times p. And variance of y is, first we need to find the expectation of x squared, here expectation of y squared. We square each y value, multiply it by the probability of each y value, minus square of the expectation of y will give us the variance of y. I hope everything is clear. Thank you very much for watching.